Hi, everyone. Welcome to CDCT Live. My name is Jason Rader, and I'll be your host for the next few minutes as we tackle today's topic, which is managing at the edge. Today, we have two fantastic folks for this conversation. We have Andrew Nelson, Principal Architect, and Darren Westman, Cloud Solution Architect, here with me at CDCT. Welcome, gentlemen.
Thanks, Jason, for having us.
So, let's, we've had several sessions up to this point talking about the edge. And, I think today's session I'm really excited about because we're kind of getting it down into the nitty gritty of how things happen. And I think also I've heard you guys talk on this topic before at an internal meeting. So there's some interesting things we can talk about based on your experience with customers and things like that. So why don't we kick it off? And we also, for you guys out there that are commenting on the previous sessions, we're taking all your comments and we wrap those around the session in the way that it'll progress this time. So please keep that stuff up. We love that. So let's kick it off and talk about maybe a little bit about the problem at the edge from a management perspective.
Sure. So, one of the things that's going to be a big challenge as you scale out an edge or an IoT platform is just the number of devices and the surface area of those devices. I think you had a previous session on security, Jason, on this topic, and that scale makes it very challenging to keep devices up to date and patched and managed and healthy. And it's a problem that's not new to IT, but the scope and scale is totally new.
Okay. Go ahead, Darren.
No, definitely. I think, anytime you get out beyond the POC, it becomes a real issue, right? We kind of start off with this really small scale and everybody says, yeah, we've got this nailed. And then pretty soon, you start scaling it and it gets to this unmanageable part, right? And Andy and I have talked a lot about this. And what do you do when it gets to hundreds and thousands of devices?
Yeah, Darren brings up a good point, as a lot of IoT pilots are done with rather inexpensive Raspberry Pis or leftover PCs, just to do a proof of concept, make sure that the data is valuable, the data flows correctly. And then if you try to roll those devices out in the field, you realize that they don't have out-of-band management, they don't have potentially dual boot-like functionality, they tend not to have all of the robust features that we're used to in the data center. And so one of the themes that Darren and I have been preaching is we're trying to cherry pick technology that comes from the data center and apply it to the edge for all of these scale and manageability issues.
Yeah, go ahead, Darren.
No, I was just going to say, think about it, right? So I think we've been addressing it at the software layer for a long time, and there's a lot of good solutions there. But where Andy is really going is when everything goes sideways, without sending two guys in a truck out to a site, how are you going to respond and take care of it?
Perfect.
Yeah, two guys in a truck is a punchline in this conversation. Anyway, go ahead, Jason.
Yeah, for the legitimate two guys in a truck out there, you guys are great, but we're talking about that's a terrible way to try to manage your environment with sending guys out, literally two folks in a truck to go do something. And so, you guys hit all of the stuff I really was excited about talking about on this topic, because I think folks are trying to, there's developers involved. There's a lot of different pieces involved in this as they're doing their proofs of concept. And so once everything seems to work, think folks get stuck because, this works at, from my perspective as a developer, or, we've put a firewall in place or some type of device that works with the scale that we attempted to do it at from the proof of concept perspective, but then, and even a storage perspective, there's all kinds of other aspects related to that scalability that we can run into. And that whole management aspect of what do you do when everything just dies or something just dies, and you've got to be able to have that out-of-band communication or things that we're used to doing in some of the other areas. And I know you guys have experience related to that you'd like to talk about too.
Yeah, and there's kind of 2 or 3 different strategies around how to mitigate that. So we're seeing in the IoT landscape specifically, having hot spares and having a digital clone and different terms like that. And that works great for smaller footprints. But and back to that two guys in a truck, if I've got to have somebody that can grab a device off a shelf and plug it in, or grab a device in a warehouse and drive it out to the location, that starts to get cumbersome. And if I've got to buy 2 or 3 of every one of these devices for different offices and locations. That gets cumbersome. So we're seeing that come from the IoT landscape. Now, I have a history earlier in my career of working in the power industry, and IoT and edge is really just a reboot of what we've called SCADA in oil and gas and the utilities for a long time. And one of the first things that I noticed when I moved into the utility industry was how expensive these devices were. It was just a little box stuck in a substation out in the middle of nowhere. So it was really just a PC, but it was a PC with redundancy and a PC with some sort of management wrapped around it, both hardware and software. And the big thing we haven't touched on is a lot of these environments are somewhat hostile. So even with IoT, we're seeing devices in kitchens of fast food restaurants and such, which is hostile for grease buildup. And so these devices need the management, but they also need to be hardened. So, and that affects this manageability in a backwards way. If I've got a device that doesn't have fans, that's fully sealed and enclosed, I'm not going to replace it and have to deal with it quite so much. So all of that hardware and software ecosystem is something that we've done before in different parts of our industry. And our advice is not to get hooked into the IoT is brand new and it's never been done before, so we have to do something different. Not necessarily. We actually have, most of our vendor partners have come into that realm with IoT or edge specific devices that are hardened, that have air filters, that have no fans or specific fans. And then they also have all of that data center out of band management like we've been talking about. And that makes a huge difference in how I re-image. So if I can get into out-of-band management and mount up virtual media, so all those terms mean something to anybody that's come from the data center, I can totally re-image a box in an automated fashion. And that's the segue into some of the software vendors Darren and I have been talking to. There's plenty of software vendors that are interested in this space to automate that literally can connect to a baseboard management controller, an IPMI device, and actually burn firmware remotely through that out-of-band box, even if the box is not functional. I mean, Darren, you and I have seen there's probably dozens of variations on a theme in that space from a software management perspective too.
Yeah, there's no doubt. I mean, there's so many different directions and ways that we're seeing this done in the field. And I'm not sure there's one size that fits all, and we've talked a lot about just the portability aspect of the software that's going on top of these devices, right? So you were hitting on the ruggedized style devices and, and what fits and what the environment is like. And then, of course, are you going to train staff to take care of those devices, or, what does that look like? But more than anything, when we start looking at the software stack, as you were starting to go into, Kubernetes comes to mind, right? I mean,
there's a general, right? But yeah, Kubernetes is the big one.
Yeah, for sure. And it just gives so much flexibility and portability and breaking apart the software stack itself and allowing just a ton of flexibility. And then, of course, do you go edge to cloud, edge to data center? Do you stay only at the edge to process the data? So there's so many components here, Andy.
Well, and you brought up a good point around the Kubernetes container pieces. There's a specific offering of Kubernetes called K3s, which is a slimmed down, almost a single file deployment of Kubernetes. And it's specific to your question, Jason, about manageability. I don't want to have to set up a whole container stack and manage the whole container stack. I want to do it as a single file out at the edge. And it's most of the same functionality, most of the same APIs, most of the same hooks, but way less management. So effectively, these devices are a small little Linux box running a semi-embedded version of Kubernetes, which both of those cuts down on the surface area and the manageability. And then all of these software vendors that we've been talking to have different ecosystem to manage that. How do we upgrade that single Kubernetes binary? How do we upgrade and patch the little bit of Linux we have there? And there's some really neat stuff happening in the Linux community to come up with a really slimmed down embedded Linux that's even smaller than an entry-level Ubuntu or Red Hat or pick your favorite distribution. So sorry, we're rambling, Jason, but it's all kind of around that manageability.
No, that's exciting. And I want to ask some more questions about this stuff, because I think folks want to hear is, so what I've heard is, the selection of the physical, the software platform, the scalability, the connectivity, and then we got to containerization, and that seems to be like evolution, and containerization is where, so people do a POC, it seems to work, they're on a certain platform, they're dealing with certain hardware, but then going to that containerized environment seems to be like the way that you go to that management and scale, or at least a good way. So what's the journey look like for folks that are going from the original POC to then a containerized environment? Is it a rip and replace, or how much of what they've already done can they leverage?
That's absolutely a great question, and it depends is the short answer.
That's the consultant answer.
This is like the old VMware journey that a bunch of us went on a long time ago. It was really easy to spin up a VMware environment initially, right? You cobble together a couple servers and some storage and make it work. And then as soon as you tried to scale and operationalize and run your VMware environment in an enterprise, the wheels started to fall off. We figured out that you didn't use the right network switches, so on and so forth. This isn't much. So in a POC, we need a container platform, and we need x86 or ARM generally is the compute, and all of that is good for a POC. The challenge is going from that POC to scale, all these other questions come in. So what does my hardware device look like? And we kind of talked about that before. I've got Xeon D, I've got Xeon, I've got AMD, I've got ARM devices. The hardware isn't really an issue. We've got that from most of the major vendors. The container substrate isn't necessarily a huge thing, because if I'm an Azure shop, Azure IoT is an offering that works really well there, and that's a container-based IoT platform. But you really want to look at your container platform probably first. And then Darren and I have been evaluating some of the IoT stacks, if you will, because that becomes interesting too. And that's your connectivity you're alluding to, is how do I move the data? How do I collect the data? How do I groom the data? How do I manage the data and move the data to the data center and cloud? And that's a little bit of the wild, wild west. And we're seeing some of the traditional industrial ops SCADA vendors start to move in there. We're seeing some new school vendors that see the IoT gold rush, if you will, starting to go there. And that's probably the biggest trick there, Jason, is picking that software stack that manages your devices and manages the data and moves the data, because that potentially locks you into specific tooling, specific cloud vendors. Darren, you're super passionate about the portability of that software, and because that's the piece that locks us or doesn't lock us into the rest of the architecture, right?
Well, I love that, right? Because as you come out of that POC, they're still reusable components. Not everything's a throwaway. And I think that's what makes containers so special and a good fit in this area. One of the things, just to quickly digress on, right, is back to the POC aspect, and what does all that hardware look like that's connecting that, right? Because at the POC level, you had one or two devices. You had maybe an access point that was already kind of on the edge of, does it fit, does it not fit? We have a bunch of users on it. Do we need dedicated? We start looking at the switching aspects and all of that. And not to dive into that, but that is absolutely part of the solution as we scale. And then, some of the areas that we've talked about, Andy, is storage, even backups. And that sounds kind of crazy when we start thinking about containers, but there's some realization here of what that data, what we need to keep and what we don't.
Yeah, we're starting to see like healthcare customers interested in this IoT approach, putting sensors on radiology equipment, having cameras in a hospital, tracking RFID tags on nurses and such. And now we start to cross over into that HIPAA realm. And so now making sure that we have some data protection around the data in transit, and we're not talking encryption here necessarily, that's table stakes. But if I've got 2 days worth of data spooling up at the edge, how do I make sure that I've got that for legal reasons and so on and so forth? And other industries will also have regulations that start to play into this, especially as you get into video, which is kind of the next frontier. But I mean, all the hardware stuff that Darren and I are talking about, the hardware is the least interesting piece of the POC to running it in enterprise, because the hardware can all be ripped and replaced. A little bit of work. It's really that software stack then that rides on top that starts to dictate, like Darren and I are super passionate about, when you do a POC, use the public cloud. Don't go buy a whole bunch of back-end processing gear. Don't go buy a whole bunch of GPUs. POC should be done in the public cloud for sure, because we can spin it up. We can get proof of value to a client. We can build the ROI use case, all that stuff without a huge capital outlay. And it's kind of that fail fast mentality too that we talk about all the time. If it's not going to work well, or if the data is not very useful, awesome. We shred the cloud environment. We toss all that old gear that we were using back in inventory. We're all good. But then when you go to operationalize, then you have the question of, do I leave this in the public cloud because it scales sort of infinitely, and so does your bill, or do we figure out how to monetize that in a colo or in a hybrid architecture where we're processing in a couple different places? And again, I'm playing into that same part, but that back-end software processing becomes very crucial. Most of the public cloud vendors have an IoT offering, and fancy enough, it's locked into their ecosystem. Funny how that works.
You just did it, man. That's it right there.
Yeah. But there's plenty of third-party IoT processing stacks that simply need a container platform, and they don't even care that it's Kubernetes. Some of them will run on Docker, some of them will run in whatever you feed it. And so that's a big push for us, is making sure that we pick that software architecture. And even in a POC, those software architectures can be used. And that's the part, Jason, that's probably the toughest to rip and replace, because that's what you're going to build your whole workflows and pipelines around, is that software stack moving data back and forth. And so that, Darren and I have talked about this a ton, is that's the portability and that's the scalability piece, that as we come out of the POC, make sure the overall architecture logically can plug into different places. And we know that anybody that's in one cloud will eventually be in another public cloud, tangible or intangible reason. That's not new in our industry.
No, and
long answer to a short question, sorry.
I love it though, but it's a gold nugget, because I think folks, that would be something as a takeaway, that, do those POCs in public cloud, but be aware that if you want to leverage what you're doing in that POC, the portability of the platform that you're using is going to come into play.
Well, Darren and I have been working on, this process this year. We've been working on putting together recipes. Some people call them reference architectures. It's basically a recipe. So I need 2 of these and 3 of these and 6 of these and 1 of these. And this is a baseline, small, medium, large t-shirt size like architecture. Something that we built with a bunch of our vendor partners, so that we've got SKUs and a framework. And to be blunt, you can do this with a lot of different vendors and a lot of different hardware, but we've taken some of the guesswork out so that we've got a foundation. So similar to a cake mix at the grocery store, if you want this to be a little bit quicker and don't want to have to do all the research, that's something that Darren and I have been working on behind the scenes with some of our peers to build a recipe that will, get you shake and bake IoT. The only piece that's not in there is the actual data models and data science. And that's where our brethren in digital innovation come into play. As we've got the platform, we've got the containers, we've got the data transport. Now put the intelligence out at the edge and the intelligence in the back-end cloud to do the processing.
The other part of that, right, is where does it make sense to process the data, and who needs the data, and how quickly do they need the data? That's a big part of this conversation, because I think, to your point, Andy, we're not doing anything new. Mm-hmm. We're moving where things are being transacted and making data available quicker to be able to make decisions quicker.
Yeah, Darren brings up a great point. So one of my favorite corollaries to this is initially, let's say we're managing door sensors out at a bunch of retail locations. Well, that doesn't take much bandwidth. That doesn't take much complexity. The device out at the edge doesn't need to have any horsepower or anything special. But this IoT journey it's a journey, like you said, Jason. And what happens if I want to incorporate my building security cameras into this? Maybe I want to do heat map tracking in retail. I want to track both my employees and my customers coming through. And I've already got camera infrastructure. So let's glue these together. Well, now where do I process that video data? Do I ship it all across my WAN links and process it in a cloud or a data center? Maybe, but probably not. Do I start to put GPUs and FPGAs and ASICs out at the edge to do some processing there and potentially other processing in a cloud? Probably, maybe. But if I've got a small little hardened device or a non-hardened device that doesn't have a PCI slot, doesn't have appropriate cooling, now I've got to rip and replace potentially yet again. And so some of that planning for the future and planning for extensibility comes into the scale conversation. Is let's make sure that we're looking at some of the future use cases and making sure that we have enough, like Darren talked about, have enough storage locally out at the remote site, or have a mechanism to add storage to that infrastructure. One of our vendor partners, not to mention names, has a really neat modular IoT chassis where I can plug in server blades, I can plug in storage blades, and the entry-level chassis isn't too terribly expensive. You don't need to fully populate it, but as you have more of these use cases, you can modularly plug in componentry. That's a big deal. And I think you touched on it in your previous security session, but along those same lines, the network transport doubles or triples or quadruples. And so having that SD-WAN-like architecture that I can plug and play different communication technologies and so on and so forth all plays into this. So again, we've built these reference architectures with and without GPU, with and without HA capabilities, because that's the other one, is initially in a POC, you might do this with just a single device. You want to keep costs down. But now we're in a hospital situation where if I lose data or lose visibility, that's a lawsuit. Or it's a retail location that's starting to use that for digital signage out at the edge. And if they can't update prices at the right time of the day during the Christmas rush, maybe they lose money. HA starts to become interesting. And that's the beauty of the container architectures, right? Is Kubernetes has HA functions sort of built into the container stack. So I don't need fancy clustering. I just might need two with appropriate networking. And so we've accommodated some of that in some of our research we've been doing behind the scenes.
You bring up a lot of interesting things, and you also kind of talked about our digital innovation side of our house, so the developer side. And when we're talking about infrastructure, the way that we're talking about it here, and we're talking about where processing takes place, where the GPUs are, how much of an abstraction is that, or is it platform dependent as to whether the developers have to be on board or whether it's just a service that they engage?
Wow, so we answer this question succinctly, and we'll solve world peace. But that's
I thought you were going to answer it. I was like, wow, I didn't think you had it.
So that's partially where Kubernetes and the container motions have come from. Is almost a nice abstraction layer for both the infrastructure folks like myself. I'm happy to run the container stack and build a container stack and update the container stack and make sure the containers are there to be consumed. And most of the development brethren out there in the field, whether they're our peers or customers, really don't want to understand infrastructure. This is where cloud came from, right? I swipe a credit card, I carve up a bunch of containers, and I have to tell the cloud I need so many CPUs, so much memory, but after that, I don't care. And there's a little bit of a gap there. So Darren is talking about data protection and some of the infrastructure services. That's a gap that we can fill managing that Kubernetes layer. But Kubernetes or containers in general helps in that conversation. Now, where it gets a little muddy, though, is some of the hardware offload, like we talked about with GPUs and FPGAs.
That's where I was thinking. Easy. That didn't seem clean. Yeah.
Yeah, well, and that's where like NVIDIA has their CUDA libraries, and so a lot of the IoT AI ML stacks just write to CUDA. That helps a little bit. We also see like some of our vendor partners have special cards with Modbus and CAN bus. One of our vendor partners has a whole data processing stack that comes with their device that helps massage and cleanse and somewhat normalize those data streams so that you don't have to know Modbus, you don't have to know CAN bus, you don't have to understand some of the legacy SCADA protocols, for example. If I want to plug into a whole SCADA network and pull data from it, a couple of the vendors have software stacks that do that translation. But you touch the nerve that there's a lot of different data sources, there's a lot of new hardware in that space, and how do we abstract as much of that as possible so developers can develop and data science can model, and they don't have to think about the substrate or the platform in any way. And that's really from a CDCT perspective, we're the infrastructure platform folks. We are trying to figure out, how do I build a nice offering that gets us right up to a fully baked container platform with some hardware processing, and then they can take it and run with it. Easier said than done, though, by far.
And, we're getting close to time here, but I mean, one of the things I think was a big topic that people wanted to talk about was security. And you talking about SCADA, when I think SCADA networks from back in the day, I'm thinking of those air-gapped, critical systems we got to keep, and so when people are taking that mindset and then applying it to now, especially when you talk about things like HIPAA, or if we talk about any of the privacy laws, and what if this is global and we're going into the EU or in other places that have even tighter laws on what you can monitor. What kind of things are you guys seeing around those things?
Well, I love the word air gap. That's my favorite. That's almost, it makes my eye twitch because everybody says air gap and it's not air gapped. But
yeah, they're saying the wrong thing these days. Yeah.
You're absolutely right. That ship has sailed. So again, from the utility industry, way back when I was in a long time ago, it was a separate network that was separate and didn't talk to the internet much at all, if at all. But almost every one of those utilities, customers want real-time billing or near real-time billing. In some cases, they want to be able to control load and such. I'm in Texas, so that's a hot button right now. But all of that connectivity and automation means that air gap isn't an option anymore. So then how do we build appropriate isolation, appropriate inspection, all the stuff that you do for a living, Jason? But that has to be built into these architectures. And then the challenge with IoT or edge is I just made my surface area way bigger. I've got networks way out in the middle of nowhere potentially, or out in the middle of an ocean, and they're going to be somewhat connected. So good solid network design is super important. Making sure that we have tunneling, encryption, network virtualization, all that, those kind of pieces built into the architecture is important. And the neat part is a lot of those vendors have started to play in the Kubernetes framework. So a lot of our security vendors, as you know, have virtualized firewalls, virtualized appliances, virtualized hooks that can be embedded in a small device out at the edge if we need it to. That's also their mechanism to doing SD-WAN. So it's data center technology. Again, the theme is a lot of the stuff in the data center is moving out to centers of data out at the edge. And some of the plumbing isn't going to look much different. It's just smaller, slimmer, and hardened.
So I think you hit on a couple of interesting areas. When we start thinking about traffic patterns of edge devices, we're looking at north, south, and east and west, right? The communication between the containers, and then of course, that communication outside of that edge. And the thing that comes to mind to me is we have now these, a lot of times, uncontrolled devices, meaning people have access to them physically. And while that used to be pretty basic, right? We would put them in a locked room. We find that go to fast food, and maybe some of those devices are sitting right out there in the open. And if somebody either A, got a hold of the network cable and got onto the network, where do they go? What can they do? But what if they physically stole the device? What could they do with it, right? What kind of data could they get from it? And those are the huge concerning things to me, because you start storing data, directly on the device, right? Is it encrypted? What are you doing with it? Those are some of the low-hanging fruit, but are pretty big items to address.
Well, and you've seen that in the devices, right? Some of them have that hardware root of trust. We've got some of these IoT gateways that if you touch them in any way, power cycle them, pull cables, it's like the old intrusion detection sensors, but on steroids. They won't boot. They won't boot unless somebody remotely triggers a specific command. And so it's all in reaction to what you're talking about, Jim. And none of that's perfect, but it's, again, the hardware and the software ecosystem becomes important for a lot of those reasons. And crypto shredding is a big deal, right? If I can't phone home in so long, what do I do with my data that's local? I mean, how long do I do store and forward, if you will? Or do I do store and forward at all?
Yeah, I mean, where I see this as a pretty big issue is the small startup companies trying to get out there and get their devices, out into the field, right? So they have this long backlog of all these things that they want to do and implement. But ultimately, you have people that want to get to a profit level right away. And so those things get left behind.
Yeah. Well, and it's again why we want to look at the data. A lot of our legacy data center vendors are either have been in that market or are moving into that market, and they're carrying some of that technology they've had. And this goes to our network vendors, it goes to our security vendors. Anybody that's been in that big data center is able to go, I don't want to use the phrase down market, but it's a smaller hardened footprint. And they're taking a lot of that technology we've had in data center environments and moving it out to the edge. That's the key takeaway here, right? Don't go look at some startup that's got 6 months experience with hardware. Let's look at a vendor that's got 50, 60 years worth of hardware experience.
I couldn't agree more.
No, I think that's perfect. Actually, it's one of those things where I go to, from a security perspective, or regardless of what it is, I go to the websites, I read the marketing, and I'm like, all right, there's somewhere between reality here and what they're saying. But yeah, betting the farm on what your massive rollout's going to be on something that doesn't have a huge legacy of understanding the space, but is very innovative. And I mean, typically, I think those kinds of organizations usually get acquired by the bigger providers. But it's, I'm fully for emerging technologies and emerging folks like that, and want that to continue. But there is a certain risk of going with the latest and greatest tech that hasn't been tried and true. Which is why they still put the hardened old systems. They joke about the 46 on the space shuttle kind of stuff. Well, that's because it worked the last time it was in space, and we just can't argue with those things.
Yeah, and these architectures don't get refreshed, even like data center. So they're going to be, SCADA systems could be there 10, 20 years.
Yeah.
Yeah, and these devices that are IoT, you're going to probably want a 5+ year ROI out of them, probably closer to 10. And so if you choose poorly, to use the Indiana Jones theme, you might be hurting when you have to go refresh that. And we're just navigating those waters, just like you talked about, Jason. I love emerging software vendors because I can refresh software much easier than hardware. But from a hardware and a platform perspective, I much err on the side of legacy established vendors because they aren't going away. And a lot of them have long-term manufacturing and utility footprints that lend themselves very well to a retail IoT deployment, if you will. Kind of the best of both worlds.
Well, guys, it's been awesome. I'd love for some final comments, like where some advice that you got coming from the field. We'll let Darren go, and then Andy, if you'll close us out.
Please.
I think some advice, number one, I mean, Insight has a great set of developers, engineers, architects that really can address a lot of this space. So I think that's what really makes our practices really powerful. The other thing that I'll leave with you, though, is there are several companies that have kind of that, I'll almost call it like starter packs. So you're not starting from zero to get out there. I mean, if you look at it, Intel has an edge software hub that has pre-baked solutions that at least get you going, right? And you don't have to make all the mistakes to get there. You start with something that's pre-baked.
Yeah, and I would pile onto that is let us be your IoT edge therapist. We don't have all the answers, but we've experienced more of the pain than you probably have. And let us just work through the challenges with you. The beauty of Insight is we've got talent across this whole spectrum in different groups, and we can bring all of that to bear in the right context and the right conversation. Sigmund Freud for IoT. There we go.
And we typically don't toot our own horns too largely on this kind of session, but I do think that having an organization like Insight available to you that's got the deep infrastructure, the deep dev, the deep security expertise when you're going into an environment like this. I mean, we have a huge amount of vendors that we work with. We've built the reference architectures. We have massive amounts of lab available to us. Those are the kinds of things that if you're embarking on a journey, you need somebody that's kind of already paved the way a little bit and who's capable of defining as you go forth with the newest technologies what might have never been defined before. So I think that it's quite comforting when I work with folks like you guys, because I know we can do anything. If it's been done before, no problem. If it's never been done before, that just takes a little bit longer.
Exactly.
Yeah. Well, thanks everybody for joining us today, and please keep those comments coming to us. We really pay attention. We really tailor the content for you guys. We hope you got what you were looking for related to managing the edge today. And some of the stuff that we were talking about here is available up on our website at insightcdct.com. Thanks for joining us. We'll see you next time. Thanks, guys.